Wei Li, thanks for having us today. We are here at CES 2024. We are here in the pavilion of Intel, and you're demonstrating here a lot of amazing stuff, especially around artificial intelligence. And you are the VP of AI and machine learning for Intel. So that's why we are really so happy to have you with us to deep dive into what Intel has been doing in artificial intelligence for the last decades, and what are the plans? What are the current projects you're working on, and what are the plans? Let's dive into that. Wei, can you tell us a bit more about yourself and your journey at Intel? You started 20 years ago at Intel, correct?
Yes.
What has been your journey so far, and how have you seen AI taking the lead in the initiatives at Intel over the years?
Yeah, so thank you, Pascal. It's very nice to meet you here. As you know, I've been with Intel for more than 20 years. It's been a quite journey going through the 20 years within Intel and basically evolve with Intel together. By training, I was a computer scientist on supercomputers. That's my PhD thesis, was a software on supercomputers. Reason I joined Intel was Intel was in the journey to transform itself from a PC company to go beyond PC to be more server, supercomputer oriented. And so it was a pretty exciting 20 plus years, and I got a chance to be on the cutting edge of Intel transformation. And I got a chance during that period of time to work with many customers, including the well-known names, National Labs and Lawrence Livermore and all these people, and all the way to the data-intensive companies like database companies like Oracle and so on. And then after that, everybody knows the explosion of mobile.
Yes.
And I got a chance to work on Android. Intel was at that time was business of making Android phones, Android tablets. So I and my team would create a piece of software to enable all Android applications and games run well on Intel platforms. So that was a pretty exciting period of time as well. Now in the last almost a decade now, we've been working on AI. So I've been touching all the exciting, cutting edge frontier for this thing here. We're starting to see how AI is changing everybody's life. And originally it was image processing and computer vision, and now it's with the latest large language model, generative AI, it's really going to be everywhere. And that's why we're so excited to see what Intel's doing and what the entire industry is doing as well. So.
Exactly. So yeah, we've seen, I agree with you, from computer vision to, it took a long time, generative models, and then now we are getting into language, finally. It took time. It took
language and also multimodal, right? So
yeah,
you're looking at some point, you have all kinds of different capabilities.
That's very interesting, and that's a very inspiring journey that you've been living. What are you currently doing, working on with your teams, and how can this help our audience, CEOs, managers in their day-to-day work, improving their efficiency for their customers, employees, productivity, and so on?
Yeah, that's a great question. So Intel is very much an infrastructure company, right? So our goal is we want to create powerful and efficient infrastructure so people can develop AI solutions and everybody can benefit from AI. So our end goal is, we're talking about AI everywhere. I truly believe AI will be everywhere. So it is a very exciting period of time right now. And then if you look at the AI problem today, the AI problem is actually pretty complex, right? So when AI initially started, more than 10 years ago, it was really mainly the researchers, AI researchers, creating these models, and the huge companies, were able to create these models because they have a lot of data, right? So how do you go from there to everyone who can actually benefit from AI?
Yes.
So there's a pretty large gap in between, and that makes it exciting also. How can we make that happen? Every company can, we want to make every company an AI company.
Yes.
And they actually, AI will be a natural part of what they do. Will be even invisible, software plays a key role in bridging this particular gap here. We need efficient hardware. We need powerful, efficient hardware because the amount of compute, the amount of data processing is going to be huge when you look at AI. In AI training, we're talking about these huge models and a large amount of data to do this thing here, right? So hardware is critical to get to that level. Now, software needs to bridge the hardware features we put in there and the platform for people to use AI and develop AI solutions.
Yes.
And so that's the ease of development, ease of use at one end, and then the complexity of large amount of data, compute on the other hand. So how do you bridge that gap? So we're doing a lot of work in between here.
Yeah, I love it. So your point is, how do we bridge the gap between having a complex system that is able to perform powerful computation and users who need more and more simplicity and rapidity in managing these systems.
Exactly.
And that's really in the middle of this, that you're trying to bring this gap to the minimum.
Exactly. So I think that's a huge opportunity. It's a huge problem, also a huge opportunity for all of us.
And we see today, for example, with the large language models that most companies are trying to build and building today, the key issue they face is this computational power that they are looking for, that is difficult to find and difficult to set up as well.
Yes.
And that's really where you can give a solution to them.
Yes. It reminds me the old days when I was a student, right? So it's similar in the sense, because at that time I was working on supercomputers. Supercomputers was very powerful, but it's not easy to do programming on a supercomputer, right? So it's the same problem in a different scale. Today the problem is even bigger. So people used to program on supercomputers, it's a small number of people. But today, if you look at AI, you're looking at large number of people here, right? AI, the AI everywhere is different from you serve national labs. So this is a very interesting problem we're trying to solve here. And so along the way, in addition to hardware, a lot of work is really on the software side. So software plays two key roles. Software is playing here. One is, can you get the efficiency out of the powerful machines underneath you, right? Because you can put in a lot of flops. The hardware can have a lot of functional units. You can do all kinds of things in terms of peak performance. But if people don't know how to program its efficiency is 30%. Then you're wasting a lot of your hardware over there, right? So how can you increase efficiency through software? So the smart software will figure out automatically. You don't want somebody in some company to actually tune the thing, because that person will be a domain expert for that particular business. The person will not understand the underlying hardware architectures, right? Because it's just impossible. It takes a computer science degree to do this stuff. So software will automatically do these optimizations to make it efficient on this thing. That's one piece.
So just to make sure I understood it well. So we are, as we said before, we have this computational power that we need to manage simply, user friendliness. And you say this user friendliness, we will get it by automating a lot of those technical tasks that would require high expertise that are very rare to find on the market, very expensive. So automating a maximum of those tasks to make the interface with the user as user-friendly, as simple as possible.
So we're looking at, these are the people like from my team. These are the ninja programmers. These are very specialized, they're very well trained, and they know how to do the work here, right? Well, once they create a software layer like this, and then when people who have a business problem, they want to create a solution, they don't need to worry about that stuff at all. They just say, hey, can I live on a pretty high level simplicity interface, a simple interface. So now we're talking about variety of levels of interfaces here.
Okay, and probably speak in a business language, not in a technical language, and have the machine understand this language and translate it into technical aspects automatically.
Exactly. So that's why we're doing multiple things here. So one is, it's a lot of work. to make it happen.
Yes.
So not a single company can do this, right?
Yes.
So that's why it's super important for us to work with the ecosystem. So we are a true believer and proponent, and also a leader and a participant of the ecosystem. And luckily, the AI software ecosystem is quite open. Yes. Majority of AI software is actually open source, right? So we've been working with a lot of partners to help nurture, grow the open ecosystem over there. And then the ecosystem over there, we're looking at how do we build the different level of abstractions to make it happen. So at the lower level, we have people who understand hardware specifics, but when you go up, you want to look at multiple levels of the abstraction. Mm-hmm. So ultimately, you want to look at a business. Let's say if you are healthcare business, can we get a abstraction only for healthcare, and
yes.
You can speak the language of healthcare and
so
all
that
that.
medical
and
doctors
the doctor
or nurses
can interact with this. Right?
Yes.
The doctor can use this in here, and maybe the data scientists in the healthcare community, they can actually speak the healthcare language and some level of interface. You can build solutions more easily over there, and then you can actually have a layer below that, which could be AI domain specific kind of interface. So it could be a set of API for natural language processing, right? It could be a set of API for computer vision. It could be a set of API for recommendation systems, right? These are AI domains. You can imagine doing that kind of level of abstraction instead of going all the way to Python. So that entire space.
And by doing this, we reduce the cycle time to develop new systems.
Yeah,
instead of having doctors asking developers that are asking experts to do all this, doctors can directly perform this work.
Exactly. So there's a fundamental difference between the developers or users we are working with when you think about large scale, think about really everywhere versus a narrow set of customers here, right? So for that one, it is it's a huge opportunity for us here.
So Wei, I think that's a great value proposition. So enabling business people, operations people to perform all this work at computational levels that are higher than ever.
Yes.
How can they concretely use it today? You talked about an ecosystem. Is it that you are the enabler for this ecosystem of solutions that are going to companies, to help companies? Or are you also bringing this directly to companies?
Yeah, so we do actually both. So one is we are heavily, closely participating in the overall ecosystem at the multiple levels of abstraction, right? So at the more foundational level, large language models and all these large language models today, quite often they're PyTorch models. So PyTorch is already a layer above a typical Python language. It's a Python package which provides a abstraction for deep learning development. So we are heavily contributing to PyTorch. Actually, we are top 3 contributor. Intel is a top 3 contributor in the PyTorch ecosystem.
Wow!
Right?
Okay. Globally.
Wow!
Okay.
Right?
Wow!
So we actually putting a lot of investment in creating help the PyTorch side of it. And most recently, as you know, PyTorch has become a true community project. So there's a PyTorch Foundation. So Intel joined the PyTorch Foundation, and I'm actually sitting on the governing board for PyTorch Foundation to help PyTorch to move further. Right?
Excellent.
So we are investing a lot in the ecosystem over there. And now we're also looking at moving up the software stack. We talk about abstraction. One of the major ecosystem player is Hugging Face, and we've been working with Hugging Face, for the last at least 3 years. So we're contributing quite a bit to the Hugging Face ecosystem as well in terms of upstreaming our optimized software into the Hugging Face ecosystem, as well as creating extensions to the Hugging Face APIs. So for example, we have something called Intel extension to transformers. As we know, transformer is the foundational piece inside all the large language models. Basically, every large language model is a transformer model, right? Yes. So it is pretty exciting.
So this is how you are part and leading the developer community, Hugging Face, PyTorch.
Yeah.
So this is at a certain level of abstraction that is for developers.
Yeah.
Now if we move up
Further.
further to the more business.
Yes.
Aspects.
So we have moved further also. We worked with Essential and we create what we call reference kits. So now the assumption here is when we reach more and more people, and there are a variety of potential customers. Most customers will not be researchers in AI anymore, right?
Yes.
They will be domain experts in whatever. We talk about healthcare, we talk about financial industry,
Yes.
and we talk about all kinds of agriculture, all kinds
Yes.
of things, right? And over there, if you're a company, you may have recently hired some data scientists, right? And so how do you enable that level of expertise, right? They're strong expertise in their business, but not necessarily AI, researchers, right? So how do we do that? So we create a set of what we call reference solutions,
Okay.
right? So if you want to do,
So
let me
business
say,
specific, or industry specific
solutions. Let's say disease prediction, right? So we worked with a hospital healthcare provider in New York and help define something. Let's say disease prediction. If you are interested in disease prediction, we have a baseline reference solution already for you, and that has a pipeline, and it will start from your data, your medical data of some kind. So the patients have symptoms and all these, that's have data here. And then in the particular reference kit, we also picked a model, an open source model. The open source model came out of MIT actually, so the open source model. And then we actually have a script to run the model with the data set, with the public data set, and also when you run the model, it uses the optimized software we have developed. So we make sure you get the best efficiency on the hardware, right? So the reference kit, it's free. You can download open source, right? And you can start from there.
You can download from where?
You can download from Intel website.
Okay, nice,
Intel. You go to Intel developer website.
Okay.
You can download the reference kit. Right?
Okay. And it's easy to find.
It's
you
very
look
easy.
for reference case.
It's just reference. Just go look for reference kits. Reference kits. You can find it, right? And so over there, you have a variety of use cases for people. And now what we have seen is people use reference kits in different ways, depends on where your business is, right? So for example, in some businesses, you may be starting from scratch. You don't have anything.
Yes.
So you have a reference kit, you say, hey, I have some complete solution I can run, okay? Now the reference kit, they have public data. So now you may have your own data. So you do need to do more work on top of this because we don't have access to your data, right?
Yes.
So you have your own data, you can use your own data, but we have the script, everything there. You can actually train the model with
it's very user-friendly.
User-friendly to use your own data here. So that's one scenario.
And it's industry by industry.
It's industry by industry.
Wow,
industry by
amazing.
industry, right?
And
then the other is sometimes you have a business where you may already have some AI solutions, but may not be the latest AI. So you may be using, the traditional. The word traditional is weird in the AI space. Like, even maybe a few years ago, you used some machine learning technique. Now you want to use deep learning, right? You may want to use so you may want to do replacement. You already have your own solution. You don't want to replace your entire solution with this thing here. So you want to say, hey, I understand what's new here, and then you pick pieces from there.
You combine.
Right? You can pick pieces. We show you this entire solution, how that look like. You can pick pieces over there.
That's very important because very often companies have invested for years
you have a
in
legacy
some use
system.
cases.
You have legacy system already, right? So we work with some company. They said we already have, I won't name names. They already have a solution built on top of the statistical machine learning side of things, right? So we're looking at a variety of use cases, and we also have a early stage piece of software where we look at another use case where if you have a bank, you have a lot of data, but your data may not be usable for machine learning, right? Because quite often you accumulate data over the years, and the data was accumulated for a variety of reasons. For most often it's for archival reasons, right? Or maybe for regulatory reasons, you have to keep the data somewhere. But it was never kept for machine learning.
Yes.
So the data may not be clean, maybe
Correct.
missing fields, and maybe all kinds of data.
In the reference kits, you have those functionalities of cleaning, preparing the data.
So we have another capability we're still early exploring, and we can actually look at the cleaning data and all
Got
this.
it.
So there are a variety of things we want to make it easy. Now again, it's simplicity with performance.
Yes.
I think that's the tough part. I mean,
Yes.
people can do simplicity without performance. That's actually easy. Actually, it's easier to do, right? You can develop something, hey, you can use it, which won't give you the performance you need.
Definitely.
That's not good. But if you do only performance without simplicity, people don't know where to start, right? So that's the hard technical problem we're trying to solve here, which actually is pretty critical for making the AI everywhere vision work here.
Excellent. So I loved this story around those reference kits by industry, easy to find for any of our audience online, and very easy to use, and they can combine it with their existing systems if they have. They can use existing data that you're bringing from the public as well as their own data to really create something that makes sense.
So company can, so it depends on the company expertise. They can go deep also, right? Because if certain companies, they have people who are really familiar with models and all these things, there's an extension called Intel extension to transformers, right? Transformers, and you can go to Hugging Face. You start from there.
Got it.
So over there, within that package, we also have reference design for chatbot.
Yes.
So now we're talking about large language models, right? Because people, I think the most prevalent application of large language model today is a chatbot.
Yes.
And people find different reasons to use chatbot, right? So over there, we actually have a chatbot design called Intel Neural Chat.
Okay.
Intel Neural Chat, and you can see it's also pretty complete. You can actually start, if you want to build a chatbot, you can start from there, and then you can fine tune depending on what you want to, what you want to do in your own organization. And then over there, you can also fine tune open source models, so you can pick the best open source model in the industry, because the models move very quickly also. The variety of models are going on today, right? But you can choose these open source models. And once you have the open source model, you can actually fine tune it with your data, because that's pretty critical, because you have your own private data, and the existing model in the industry, they may not first of all use the latest data to begin with, even the public data, right? They may be using data from 2 years ago, right? And so that's updating your data. That's one opportunity here. And the other is your private data. You don't necessarily want to give your private data to somebody else. You don't want to upload somewhere else.
Definitely.
So you can actually do training within your own data center or whatever, right? So you can do fine tuning over there. And then there's different capabilities, technologies that we've been creating. Some of the technologies called RAS. So you use that capability, you can actually create a database with your own private data, and that gives you the more accurate information. And with this, you can actually use a smaller model, maybe 7 billion model, maybe instead of creating a trillion parameter model for this, you can do a small model for this. So as you
I heard about those solutions where you can build kind of your own ChatGPT for your company that can retrieve the information from your company. You can, I was dreaming about this, having around the board meeting, having one of the directors being ChatGPT equivalent that is able to tell you that 3 years ago we've launched the same campaign, it didn't work, so why should it work this year? Really being able to
it's customized with the information for that particular case, right? So actually, I'm part of the keynote here, where I actually have a demo. We can create a chatbot for CES 2024 to answer questions specifically for CES 2024.
You can give it all the knowledge you want to have.
Exactly. So we fed the CES 2024 information into that chatbot to allow you to answer these questions more easier.
So those are great examples, great illustrations of what we can do with the reference kits and all the material that is available
Yeah,
there,
so,
all
so
the resources
references
that are
is
there.
one part of it, and the other is the eye tracks, the toolkits. So we're doing
toolkits, okay.
toolkits. We're doing toolkits to enable people.
So all this
to
is
do
in the
this.
same place in the Intel.
All the Intel developer website has
okay,
all, we
excellent.
have all kinds of toolkits over
Excellent,
there.
excellent.
People can find these things.
Excellent. Well, very important question for the audience that is watching us is, they might have already some applications in artificial intelligence. Maybe some of them don't have at all. What are the first steps to go into artificial intelligence, to bring in their company the capabilities of artificial intelligence? What would you recommend? Where should they start? What are the critical success factors they need to get right from what you've seen?
So it is actually, that's why we're looking at the problem here. It's actually not straightforward today, right?
Yes.
That's why we're building all these capabilities. So it is not straightforward. And I've seen companies who tried and then didn't get much out of it, because really you run into many practical issues very quickly, right? So one of the issues I mentioned earlier is even starting from cleaning data. That's actually already a challenge for a lot of people, right? So can you get the data ready, and then once you have the data, can you get to the pick the right features you want to implement, and then you pick the right platform, and then where the infrastructure you want to develop your solutions on, right? And
so one of the first step would be have a look to the data you have, and the quality of this data.
Yeah.
For this high quality data, can you start doing something, a use case that would be useful, that would answer one of your business issues or business
what are the
improvement
business
opportunities?
pain points you have?
But I think it's first we start with business issues, and then we identify where in the data do we have those quality data that would help us to implement those.
Yeah, exactly. I'm going to give you an example of what we do ourselves, actually, maybe closer, which is, we're looking at, on our website, we have a chatbot providing customer service to Intel software. So people can go to type what is this XYZ Intel software, right? And you don't really, you get some information, but it's not, it could be better, right?
Yes.
So our team got in, and we say, hey, with the large language model, can we make it more conversational, both conversational and more precise information? So in that process, we learned quite a bit in terms of going from more of a researchy sort of exploration kind of stage to a real production deployment. There's still quite a bit of gap, actually, to make it happen here. So in order to get to a real business solution, the solution needs to be more complete, and that's why we're working on all of these things here. Excellent.
And I heard you talking a lot about expertise and developers and business people. So basically the expertise, finding the right talents in the company and bringing them together might be as well a critical success factor.
Yes, and find the right set of people to work on this is going to be critical also, because when you create a solution, you need people who have deep domain expertise on your business to begin with, right? What problem you're trying to solve here, and then you need a data scientist who understand the data side of it, understand the model side of things, understand what's available in the industry, because the industry is also moving very fast. I live in Silicon Valley, because wherever you go, there are a lot of people doing startups, right? I mean, there are all kinds of, we're creating a lot of projects. So there are many solutions being developed as we speak. And so you potentially have a lot of different choices to choose from, and look at, how we want to, what kind of solutions you want to develop over there. It's the right set of people with the right set of tools, and also the right set of, then eventually get down to the hardware side of things, what kind of hardware you want to do acceleration on, right? And there's also cost issues and all these things. That eventually comes down to whether it's cost effective to run it on certain platforms and so on.
So prioritizing the use cases based on the cost and the benefits.
And the benefits. And then different platforms, as we find out, the different, eventually it comes down to the hardware side, and different hardware platforms have different capabilities and different trade-offs in terms of cost and performance and all these things, right? And so, one of the things hardware we've been working on, Intel's working on, is a Gaudi accelerator.
Yes.
And the Gaudi accelerator, one of the partners in the ecosystem called Databricks, they published a blog recently, and when they evaluated large language models on different hardware platforms, they found the Gaudi platform to be the best in terms of training performance per dollar. Right, so if you care about performance per dollar, so that's actually give you the best platform for both training and inference. So Intel, when we develop a variety of hardware for AI, and one end is we have a special purpose hardware only designed for AI, and Gaudi is the name for that product for the special accelerator for AI. And then the other end is we're actually adding AI acceleration to CPU as well, which is general purpose. CPU can run all kinds of workloads, but we're adding AI to it, so you can actually run AI workloads on CPU as well. So and then these are the two ends, and then we also have something in between. We have a GPU as well. So Intel for the hardware products, we have a variety of product lines here. So it's pretty broad. We do a lot of stuff.
Yes. I'm still in the point of what should we recommend CEOs or managers who want to start or increase the scale of their AI initiatives. So we talked about talents, we talked about getting the right use cases, finding the right data. I was thinking as well, and you explained your story at Intel, starting small in AI many decades ago, and having a vision, starting small with the proof of concepts or pilots, showing and seeing that it works, and then scaling it. And all this along a vision that you've defined from the beginning, and that might be flexible, but gives you at least the right direction.
Yeah. So I think directionally, we will see AI everywhere in every application. Now the question is, how can you get from today, wherever you are today, to a deployed AI solution quickly? That's actually a question, open question. It may not happen. It may not be in 3 months you have an AI deployment, right? That's probably not very realistic, right? So having a vision and go somewhere, and then have a strong commitment, and it will take some time to get there, because your company's infrastructure may be a little bit far away from AI today, right? So it takes time to transform your entire infrastructure to get there. The POC process is important, proof of concept to begin with, and you learn a lot along the way, and then you need we talked about earlier, you need the right amount of kind of data, you need the right kind of people, and with expertise, and how you get there, it will take you need to find the right set of infrastructure to develop your solutions on. So these are all relevant.
Thank you, Wei. That's
and
really,
then the other thing is
yes.
the changing. AI is changing very quickly, right? So you need people who can actually track the greatest progress in AI as well.
Very, very important. I really believe that having a kind of a center of excellence or experts that are able to look on the market, what's happening, and be able to pick what is relevant for the company and infuse it into the current programs, so that
and people need to be able to adapt quickly, because whatever we talk about today, tomorrow may be something different, right? So that's key.
Yeah, excellent. And I wanted to come back on one of the points that you mentioned now, which I found very, very, very interesting and very realistic as well. So implementing AI in a company today will take some time and will take some talents, and I think we need to be realistic about this. When we say time, it's in months. We need a few months, but it's not in days, not yet. But the return now, we know that it is here, and AI is here to stay. So investing right now in an AI solution completely makes sense, and is the right investment to do. Right investment in terms of infrastructure and solutions and development, but also expertise, talents, and also data, and so on. It's really about maturing the company, the culture of the company. We can get to the culture, I think, here. And the company towards being ready
will be here, right? So if you don't invest, you will be left behind. You will never be able to catch up, right? So this is a fast-moving game right now.
I love it. Thank you, Wei. Just last question: what are you working on, or will you be working on soon to move again all this even further?
Yeah. So on the hardware side, as a company, we're investing heavily in AI. So we have, as I mentioned already, we have a variety of product lines, all the way from special purpose AI and to the general purpose hardware with AI acceleration on top of this, right? So the range of AI hardware solutions we're providing here. And on the software side, what I would say here is we'll continue the journey we started, which is not only looking at the low-level software, but also moving up in the software stack to make it easy for people. I think directionally, in terms of our investment, right? Directionally, this is a key opportunity for all of us here in the industry, not just Intel, right? So Intel is part of this journey to make it easy for people to do this. Now, again, over there we're looking at two ends here. Well, one is we continue to look at cutting-edge technology, breakthrough, and then the other is make it available widely.
Yes.
These are two things. So on the cutting-edge side, for example, we're working with the Argonne National Lab, and one of the things we're working with them on is they're building a huge supercomputer. It's like 60,000 GPUs, and it's not a small number to begin with, right? And then they're also starting a consortium to build a very large language model, which has 1 trillion parameters.
Okay,
that's
nice.
a pretty large model, right? And for science, so they will be taking data from scientific community. The model will be used for the many different disciplines of the scientific community, all the way from biology, cancer research, all the way to cosmology, right? So from small to big, you can. So that's a sort of more of a cutting edge thing we need to continue to do. But then on the other extreme is we need to look at the smaller things to make it a smaller model, smaller large language model. It's a weird way of describing it, but a smaller large language model work for everyone here.
And for phones, for computers,
for laptops and all that. So I mean, we made a smaller model, like 7 billion model, work on the laptop, on AI PC, right? And actually, by the way, as part of the ecosystem, we're doing quite a bit in terms of getting the best model fine-tuned. So this is a pretty interesting area we're working on here.
Very, very interesting, very exciting, very exciting. Thanks for sharing with us. I was wondering, when we talk about supercomputing, are we talking about quantum computing or not?
So the supercomputer we're talking about is still not quantum computing. Now, Intel as a company, we actually have a research lab working on quantum computing.
Got it.
Working on both quantum computing
different
and neuromorphic computing. These are all different forms of computing from the current architecture here. But the supercomputer I was talking about is actually still, today we're building it as we speak, and these are the GPUs we've been developing.
Excellent. Thank you so much, Wei. That was really, really interesting, very insightful. Thanks for your time, and I wish you a great CES 2024.
Yeah, thank you for the chat. I certainly enjoyed it, and hopefully it's useful for your audience here.